This video covers the activities and exercises for Thursday. With regards to data collection, the question of the day is, what was your favorite part of yesterday? As in every other day, you will document by taking pictures and recording presentations. You'll start off your day by creating your teams. Make sure you address any negative patterns that you saw in the previous day's team formations and try to get some balance. The underlying theme running through the day is complexity, and there's a number of exercises that we'll do that will address that. There's also more exercises than you can probably cover, and any one section could spread out quite a bit. So it is up to you to select what you feel more connected to and what you think would work best with your group. The very first exercise is one in information hiding. This is one that is pretty relevant, especially in the medical field. And this is a simple example of it. In this example, the very first person, and you can do this within a team, chooses a random number that they keep secret. They then add to that random number their allowance, and I chose allowance just to choose something that the team would have sensitivities about. They would add to that random number their allowance and would hand out on a new note that paper to the next person. The next person would keep that number private and would add their allowance number, and you would do the same thing all around the group till you got to the end. At the end, you can subtract that initial random number divided by the number of participants, and then you would get an average allowance. And you could do the same thing with ages and many other things. The next broad topic of the morning is that of sorting. And this is one that, unless you've worked in the field, it is deceptively difficult. And most people would think it is a trivial issue. And so this is an opportunity, this very first part of the exercises on this topic, to understand that it's not as simple as people may think. And so one of the things that I did was I brought up everybody from class. I wrote random numbers on index cards. I then handed it to them face down and told them to not look at it until the end. And then at the very end, I told them, flip your cards and order yourselves. Now this should have been an opportunity for a lot of fun, comparisons, and so on. And it was a bit lackluster. They went through the activity, they did it. There was some awkwardness, as there might be in trying to do this, but it didn't work that well. Now the next thing to do is to ask them to create a sorting scheme. And this is the sort of thing, again, that may seem trivial to come up with. And it is not an easy thing. The sorting algorithms that exist have all been breakthroughs. And so this is an opportunity then for them to see how difficult this is, and you can quiz them and see and get some discussion going on what it is that they have constructed. Now, once they've done that and they've had an opportunity to see the difficulties and the challenges, you can introduce them to bubble sort. Now, this is the simplest possible algorithm. Because of its performance issues, it is often not taught, but it is a very powerful one to use in a physical setting because you can see how people would bubble down the line in a sorting algorithm. Again, this is one that I did with a group last year. It was medium success. There was some ahas, but not a thrilling success. Now, you could do the same thing with merge sort. It requires more coordination and more understanding of what's taking place. I did not cover this, but I included just as an additional option. Now, once you've been through both of these, you can also demonstrate the speed of them, and that is a classic thing to do, to show the illustrations and animations side by side. You can see the different potential of different algorithms running side by side. And that is a good way to explain why you would want to run one versus another. Now, going back, as I reflected on what took place within the classroom, and I thought about the possibilities of how this could be made more engaging, I thought about doing the following. Not just sorting a number, but sorting around categories and then order within the categories. And I thought that each category could have a sentence and each word in that sentence could have a number. So say, for example, if category 5 had I love you, I would be 1, love 2, and you 3. And you can make them longer to make it more challenging, but you can see how teams would first have to understand what group they belong to, and then within the groups sort themselves, and when they were done, they could shout out their sentence. So this has the potential to have a better fit to what I saw in the classroom. You will tell me whether that's the case or not. Another topic that I addressed, and I did do this one in the classroom, was that of complexity of getting a certain number of heads or tails in a row. And this could be the same thing as when you're trying to do a hash that has been requested of you, where the first string of characters are either zeros or ones. And so you can put a sequence of girls in a row, and you can ask them to flip coins, and you can increase the number of heads or tails that you want in a row, and you can see that as time goes by, it becomes harder and harder. And again, this is a good way to explain the measure of complexity. The next one is the classic traveling salesman. This is a problem that everybody can connect to because it is very close to real life, or real world, I should say, and that grows in complexity very fast. As you can see here, if you have 3 routes, if you have 3 cities, you have 3 routes, and if you have 10 cities, you have 1.8 million routes. So this is a good way to illustrate it. You can create dots and stick them to the ground. You should have yarn within your class as well, where you can connect the dots with these lines. And this is one that I skipped. Instead, I opted for using Towers of Hanoi because I believe that was the same message and a lot more fun to do. However, if you decide to do it, one of the additional activities there to point out, and one that could be successful, is to ask them to, without solving it, traveling salesman algorithms or problem is a very challenging problem, is to identify scenarios in real world that are traveling salesman problems. Now, and one last note that I made here to myself is maybe we should call it traveling saleswoman as opposed to traveling salesman. And the last activity of Thursday is that of Towers of Hanoi. This is one that we have covered previously, so I won't go into depth. The goal here is to highlight how the complexity grows as additional rings are added. And once everybody has mastered it, you can break up into teams and practice and master. And once you have done that, then you can bring the teams together and there can be competitions. And this was a great deal of fun, as I've shared with you before. Now, when it comes to the afternoon, this is Thursday afternoon, and all of the afternoon is dedicated to working and finalizing what you're going to present on Friday. So there is a single task, and you should walk around and work with the groups, make sure they understand what they're supposed to deliver, what the expectations are, make sure they're not stuck on still trying to do something that is too hard, or that are not simply so high level that it's hard to know what they're doing. So with that, we get to the end of the day. Remember to submit your reflections. Remember for both TAs and instructors, and for students as well. And so with that, we'll close Thursday.